The initial step in the mill process begins as the logs are fed into the mill via wave feeder. The logs go through a rotating ring containing knife arms in the debarking process. The bark is sent to a boiler that produces steam to dry lumber later in the process. After being debarked, the logs are scanned by computer-operated cameras in order to determine cut lengths. Each log is scanned by a laser curtain. Information about the true shape of each log is then sent to a computer. Computer sets the saws to cut the log into lengths that will produce optimum value. The logs are kicked off the conveyor and fed into the VFM merchandising saws. These saws are on an infinite track, enabling precise length cuts. After the cuts are made, the logs proceed onto the mill infeed conveyor. The logs are scanned again and then rotated before going into the first set of saws inside the mill. The scan data is fed into a computer, an optimum rotation solution is determined and sent to the log rotator. After rotation, the log continues on its path to the twin vertical band mill. Just before going through the twin vertical band mill, the log goes through chipping heads on either side. These chipping heads take a small face from the side of the log, typically ½ an inch wide. The log then travels through twin vertical band mill. The centerpiece, called a cant, is cut out. After the twin, the center cant travels downstream and is offloaded to a conveyor that takes it to the curve sawing gang edger. The sideboards fall off for processing. The sideboards that fell off go to a twin horizontal band mill. This cuts the board to proper thickness. The sideboards are fed out of the twin horizontal resaw and moved to the optimized board edger. At the optimized board edger, the boards are scanned, skewed, and then sent through saws that cut off edges, making each board's edges square. After passing through the board edger, the board travels to the finished lumber line. The center cant from the first primary breakdown is now processed. A machine called the curve sawing gang edger is used. It has 10 vertical round saws. Traveling through this machine, the cant is cut into boards, as many as 11 at one time. One impressive thing about this machine is its ability to follow the curve of the cant. Even if a cant has a significant amount of curve, this machine can process 15% more lumber than if the same cant were processed with old technology. Old technology would chop the curved part off, leaving less lumber and more chips. The finished lumber then goes to the lumber line. Each board passes under another scanner optimizer and is trimmed to optimal value length. The boards are then evaluated for moisture content. Rough green lumber can have between 20 to 80% moisture content. Moisture content determinations allow the boards to be classified for the drying process. This enables maximum efficiency for the dry kilns and minimizes over and under drying. Good drying is an important factor in final value recovery. After trimming, the boards are sent to a 62-bin sorter where they are dropped into the designated bins. For example, there's a bin for 16-foot 2x4s with less than 60% moisture and one for 16-foot 2x4s with a 40 to 60% moisture level. The load of boards is presented to the stacker line where it is placed into layers with small boards or stickers in between each layer. This configuration enables the lumber to dry efficiently. The units of lumber are then taken away by large forklifts and sent to the dry kilns. They are dried at temperatures ranging from 150 to 230 degrees. Dry times vary from 25 to 70 hours depending on the species. The units of dry lumber are put on a large tilt hoist. Each layer is then fed onto a conveyor. The boards are passed through another moisture detector. Boards that exceed a 19% moisture level are kicked out for re-drying. An operator looks at each board to make sure it is oriented for presentation into the planer machine. Boards are flipped by hand if necessary. The boards are then fed into the planer. The planer is a machine with 4 heads. Each head is a drum configured with 26 blades. The head spins at 3,600 revolutions per minute. As the board passes through the planer, a thin layer of wood is shaved off by the spinning heads. The end results are a smooth surface and accurate board size. This is an important precision process. Each board that comes out of the planer is accelerated on a belt conveyor and taken to the finished lumber line. Each board is graded as it passes under 4 high-resolution cameras. The computer combines these 4 images to determine any defects. Machine-caused defects are splits, broken edges, holes, or machine gouges. Pathological defects include rot, knots, or wane, the rounded edge of a board that was on the outside of the log. The grading machine then determines the quality of each board. The grade stamp is sprayed onto the board. It then goes through a trimmer that cuts the board to exact lengths for final sale to customers. The computer knows the grade of each board and each lug space. The boards travel up a large tower and are then kicked off onto the appropriate tray. Once a tray has a full unit, it is offloaded to the stacker. The lumber is then banded and paper wrapped for final shipment to customers.